All right, so let's take a look at this. So the way these work, let's talk about the ideas, okay? So we learned, wow, people are already leaving now. All right then. So we learned how to do it using a graph, right? We learned how to do it through substitution. No, elimination, excuse me. Where we basically created opposite terms. And now we're going to do substitution. Now, substitution, the idea behind that is to solve for one variable. So we're going to solve for X or Y, and then we're going to plug that value in. So watch how this works, okay? Let me get a piece of paper. Since we all know I can't write within small areas and have it even be remotely legible. So let's look at number one here. We have y equals negative 2x plus 4 and y equals 3x minus 6. I was telling Mr. Henry that you guys were doing these like they were like stupid easy, and he's like, well, that's encouraging. I said, yeah, they're like, so they're not having any problems doing the systems of equations. He's like, oh, good. So that made him very happy. So the way this is going to work is, you see how both of these are set equal to y, yeah? So if these both equal y, then this is also true. Isn't it? Because remember, we learned a long time ago, if A equals B and B equals C, then A equals C, right? If and then. We learned that like a million years ago, right? We learned that back in elementary school, didn't we? And so this is a basic idea of how mathematics works. So if I have a number that is shared in between this B and it's equal to A and C, then A and C are also equal. So if I think of this as being B and A and C, then it kind of works like that, doesn't it? So that means I can let A and C set them equal to each other. And now I just have an equation to solve, don't I? So I'm going to solve it by adding 2x. Then what should I do? What should I do now? Well, don't rush all at once to answer the question. You know, just take your time there. Yes, Allie?
You would add the 6 to the 4.
So now I have 10 equals 5x, which is obviously going to be 2 equals x after I divide both sides by 5. All right? So that's just like really stupid easy, isn't it? Now, here's the deal. If you look on this worksheet, you'll see that I gave you some that are typically substitution or elimination. You can see how all of these are like elimination, and these are all substitution because they have y equals. But the reality is that sometimes we're going to get weird problems that we're going to have to look at and figure out which one's going to be easier. So I'm going to write a problem here just as an example. No, not 2x. I'm going to do like 5x plus 10 equals 15. Oh, wait, no, I need a 15y, excuse me. So now when I have something like this where you're like, oh God, I'm going to have to multiply some really big number to get this to work, right? Because I can multiply by this by 5, but then my numbers get really big. But couldn't I also just take one of these and solve for one of the variables? I mean, I don't have to have a solution, But let's say I did this. Let's say I decided to divide everything by 5. Here. Now I get x plus 2 equals 3y. Now watch this. I'm going to subtract 2. And I get x equals 3y minus 2. Well, can't I take this now and substitute it in on the top one for x? Because if this equals x and this is x, can't I just take this value and put it behind 6 and multiply it by 6? It's the same idea, right? So the point of learning both of these methods, both the substitution and the elimination, is that it gives you the flexibility to look at any problem and go, which of my techniques is going to be the best one to use in this situation? Because sometimes you got really weird stuff where there's no obvious way for these two to get matched up and work, okay? So you may run into a situation where it's better to use one of the equations and solve for one of the two variables and then plug it in. Uh-oh, what did I lose? Julie, I haven't checked you in yet, but I will in just a moment, okay? Let me do that right now. Questions on that? Does that make sense? Does that seem like a pretty easy process? Are you surprised that people have problems learning this? And yeah, I got you, Jacob. Are you surprised that people in 8th or 9th grade have problems doing these? Because I don't see why they're difficult. I think they're really easy. The substitution ones are really simple. Let's do some more of these elimination ones. Do you want to do a few more of those just to kind of get a little better at those? What do you think? Anyone? Bueller? Bueller? Anyone care? Is anyone out there? Hello? Oh, another really quiet. Jacoby says no. Okay, Jacoby, well, you get the rudeness award today. Let's do one of these. Let's look at number 13. Now, I know you didn't, Jacoby. I'm just giving you crap. Now, I could obviously multiply the top one by 2, right? If I multiply the top one by 2, then this would become the opposite term to this one, right? So I can do that. But I could also solve for y on this top one, couldn't I? Couldn't I just move y over and 12 over and solve for y? Let's see what that would look like. So that's what it looks like after I moved y. Now, if I subtract 12, now I could take this amount and swap it in here, couldn't I? Actually, I can swap it in right here if I wanted. But we could swap it right in here. But otherwise, we just multiply by 2. And that's going to give me negative 14x minus 2y equals 24, right? So when I add these together, I'm going to get negative 17x equals 34. Make sense? So now I have my value for x. I can plug it in right here if I want. So I get negative 7 times negative 2 minus 12 equals y. So I get 14 minus 12 equals y. 2 equals y. So my point's going to be negative 2 comma 2. Yes, no, maybe so. Give me a thumbs up if you're awake and understanding this. Give me a thumbs down if you're dead. and you can't hear me, give me a thumbs down if you're dead. Okay, Jacoby's dead. Yeah, yeah, all right, all right. All right, so it looks like we need to do another one because I got people going, not so much. Oh, this is a good one. Well, no, let's not do the icky one. Let's do number 14. Now, there's two ways that I can see that we can solve this. I can multiply by a -1 on the top, and that will make 8y the opposite of this term, right? Or I can multiply the top term by a -2, the top one by -2, and that would make this by 2, excuse me, multiply by 2, and this would become the opposite to 6x. Either way is fine, right? It doesn't really matter how we solve it. What matters is that we've done it correctly mathematically, right? So, yeah. Also, you want to see another interesting idea? What if I took this and I solved for 8y? Could I take whatever is left over and plug it in here? Yep. Doesn't have to be just y. If it's the same term, it's still a equals b, b equals c, right? And therefore a equals c. So I could also do this. And then I could swap this in right there if I wanted to, because now it's 8y and 8y. Still works, right? It's the same thing. It's the same term, so I can add it in, right? It's not cheating. It's just a different way of looking at it. Do you see that? However, I do think that the easiest way to do this is simply to multiply by -1 here. So this becomes 3x, -8y, -9. And this goes bye-bye. And I get 9x equals -27, right? When I divide both sides by 9, I get x equals -3. Yeah? Yes, no, maybe so. Okay. Aaliyah's getting it. Yusuf has it. Here comes Salvador. Your brain wants to explode. I would just tell your brain no, that exploding is not an option today, and tell it that it's not in charge. All right. Any questions then on this material? Any questions? All right. So we're good. Let me stop my recording here.